Alright, we're on lesson 4 of our statistics unit called creating a histogram. So here's a look at our first problem. The boys and girls basketball teams at Roosevelt Middle School wanted to raise money to help buy new uniforms. They decided to sell hats with the school logo on the front to family members and other interested fans. To obtain the correct hat size, the students had to measure the head circumference, or that distance around the head, of the adults who wanted to order a hat. The following data represents the head circumferences in millimeters of the adults. So we see our data is right here. The hats come in 6 sizes: extra small, small, medium, large, extra large, and double extra large. Each hat size covers a head span of head circumferences. So this is going to be important. It says each hat size covers a span of head circumferences, meaning a small doesn't fit just one size like a 510. It will fit 510, 511, 512. That's what span means. It means multiple. The hat manufacturer gave the students the table below to show the interval of head circumferences for each hat size. The interval of 510 to less than 530 represents these circumferences from 510 to 530, not including 530. So this part is important. Notice that this sign right here is a less than. It's not less than or equal to. So if we get a hat size that's 530 exactly, it's going to go to the next one down. Alright, so let's fill out this frequency table. So remember from yesterday we filled this out. I'm going to count how many I have in this range. I just tally them up. Well, here's a 513, so I put a mark. 525 and a mark. 531. Oh, that one's too big, so it's going to this next one down here. 533 and a mark. 535 and a mark. 500 and oops, 1, 2, 3 35s. 1, 2, 3, 4 because of that one. Then 542. 543. 546. 549. Okay, let's check that. I see 1, 2, 3, 4, 5, 6, 7, 8 in here, and I have 8 tallies. Let's see if we can do one that's a little bit faster. Now I'm seeing that I'm in the 550 to 570 range. So I'm going to see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I can easily just mark it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now let's do it with the next one. 570 to that 590. 1, 2, 3, 4, 5, 6, 7, 8, 9. I put 9 tallies. 5, 6, 7, 8, 9. And then there's 1, 2, 3, 4. 1, 2, 3, 4, and that 590 is 610. I'm just left with 1, 2. Now, what do I do next? What do I do to complete this frequency table? Well, what I do next is I just count up my tallies and just write a numerical number. I'm just writing it out as a normal number. And that is our frequency table. So let's continue our problem now using this frequency table that we've constructed. Okay, if someone has a head circumference of 570, what hat size would they need? Well, let's look. 570, I see it here and here. So does that mean they can order a medium or a large? No, what that means is, remember, this little sign is a less than sign. It's not less than or equal to. So medium has to be less than 570. Since 570 is exactly 570, it's not less than. So I need to order a large. Alright, let's keep using this frequency table. What hat size does my data center around? Well, we still don't have a formal definition for center, but I do know that center has something to do with the middle. So what I can do is I can look and I see that this data right here, that looks like it's in the middle. So that was my what hat size? Well, if I need to, I can just roll it back up here. That was my medium hat size. So I'm just going to type that sentence out for us. Medium. Now let's look at this next one down here. Describe any patterns that you observe in the frequency column. Well, it's asking for us to describe our data. I see that it starts off small, gets larger, and goes back down. So that's really the only pattern I see. The numbers start small, but increase to 15, and then go back down. All right, so now let's go to another example. All right, a student looked at the tally column and said that it looked like a bar graph turned on its side. A histogram is just like a bar graph, but there's one difference. The horizontal axis is a number line that is marked off in equal intervals. So this is our key part. Equal intervals. A bar graph has just one number that it is responsible for showing data for. Histogram is going to show equal intervals. So this could be 1 to 2. This one might be 12 to 13. But it's going to be that equal intervals that we'll see. So here are steps to make a histogram. Step 1, draw a horizontal line and mark the intervals. Step 2, draw a vertical line and label it frequency. Step 3, mark the frequency axis on a scale that starts at 0 and goes up to something that is greater or larger than that last number in the frequency table. Then for each interval, draw a bar graph over the interval that has a height equal to the frequency for that interval. Seems like a lot of work, but it's actually pretty easy, and we'll see that when we make an example. Okay, so here we go. I'm using this data to do what? I'm using this data to make my bar graph, or my frequency. So let's begin. Complete the histogram by drawing bars whose heights are the frequencies for those intervals. Well, let's look. We already have this from 5 to 10. Well, that was this range right here. So my 2 is shown as being up 2. Now let's look here. My 530 to 550, that next one is 8 high, and I see that 8 there. My next one, head circumference, is 15. So that's going to be this interval from here to here, and it's going to go up 15. So I see here's 14. 15 will be halfway in the middle. So let me just draw a nice straighter line. And then my next one is what? 570 to 590. So that's going to be this group right here. So that's 9 high, in between 10 and 8. My next one is 4 high. And my last one is just 2. So let's see if I can move all of this over. Oh, looks like I'm going to have to erase it. So it was just too high. But now I have it in a graph format, so it's going to be easier for me to read. Okay, so we have completed the histogram, and now it's going to ask us these questions. I'm just going to trace this histogram so it will follow us as we move down the problem.
Welcome to a lesson on histograms. A histogram is a bar graph that represents a frequency distribution, as we see here below. The width represents the interval, and the height represents the corresponding frequency. Notice there are no spaces between the bars. So looking at the given histogram, notice how the intervals have the same width or the same size, which once again means the bars have the same width. These categories here, or the intervals, are often called the bins. And then notice the vertical axis indicates the frequency, so you can easily see that the mode of wait times is 4 to 5 minutes. Looks like it occurred 13 times. Now let's construct our own histogram. Here we're given data on average gas mileage of 20 cars. So before we create the histogram, we'll complete this frequency table where we already set up the intervals. Once again, notice how they have the same width or the same size, and there are 7 intervals here. We can say we have 7 bins. So we'll first go through and tally the data in the correct interval and then find the frequency. So starting with 24, which would be in this interval, then we have 17, 14, 22, 25 and 26, both in this interval, 38, 42, 24, 12, 28, 19, 32, 21, 35, 28, 21, 31, 18, and 19. And therefore the frequencies will be 2, 4, 5, 4, 2, 2, and 1. So we'll use these intervals or these bins along the horizontal axis, and we'll use the frequencies along the vertical axis. Let's go ahead and set this up. Starting with the intervals of the bins, we'll divide the horizontal axis into 7 equal intervals. So 1, 2, 3, 4, 5, 6, and 7. So let's go ahead and label them. The highest frequency is 5. Let's go ahead and have a maximum value here of 6. Break this into 6 equal pieces. And now we'll construct a bar for each bin or each interval. So if the interval from 10 to 14, the frequency is 2, to make a bar with a height of 2. The interval from 15 to 19 has a frequency of 4, so we make a bar with a height of 4 over this interval. The next interval has a frequency of 5, so we make a bar of height 5. The next frequency is 4. The next 2 frequencies are 2. And the last frequency is 1. And here's our histogram. And once again, we can see that the mode would be the interval from 20 to 24 for this data of average gas mileage in miles per gallon. I went ahead and created the same histogram using some software with the same results. This histogram was made with Excel. There is one more thing I'd like to mention before we go. If there are no breaks in the data, then normally the last data value of a bin is the first value in the next bin. For example, looking at the given histogram on heights of black cherry trees, notice how the horizontal axis is labeled by 5s. So this first interval or first bin looks like it goes from 60 to 65, and the second bin or second interval goes from 65 to 70. So the question becomes, where is the 65? Is it in the first bin or is it in the second bin? And it's actually in the second bin. This first interval is from 60 to 65, where if we use interval notation, it would be closed on 60, meaning it includes 60, but it would be open on 65, meaning it does not include 65. The next interval would be closed on 65 and open on 70. The value of 70 would be in this third interval. The third interval would be closed on 70 meaning it includes 70, but open on 75, meaning it does not include 75, and so on. So it is important to keep this in mind if you see a histogram labeled as we do here. I hope you found this helpful.
Based on the histogram, describe the center of the head circumferences. Well, this one's going to be fairly easy as well. Why is that? Well, it's the same as when we had that frequency table. So we can still use almost that exact same sentence, or I can change and modify it to the center of the data is around 560. Now, here's something interesting. We see that this bar graph right here is my center. That is 550 to 570. Why do you think I put in this one the center is around 560? Well, the reason why is we know that this range is obviously the center, but what's in the center or the middle of this range? Well, 560 is right in the middle, so I can also use that number to describe my histogram. All right, so now let's ask this next question. How would the histogram change if you added head circumferences of 551 to 560? How would that change? And actually, we're going to skip this question. So now let's go on to our next one, number 8. Because the 40 head circumference values were given, you could have constructed a dot plot to display the head circumference data. What information is lost when a histogram is used to represent a data distribution instead of that dot plot? So what happens if I am using instead a histogram and not a dot plot? So let's look at their comparisons. In a dot plot, I see each, and here let me move that out of the way for us. I see each value, or each individual value. What happens in a histogram? In a histogram, it's a little different because I only see a range. So in that histogram, I'm not just seeing each number appear, I'm seeing them grouped together. So if I want to see a group of numbers, a histogram is better. If I want to see each individual value, a dot plot is better. All right, let's go on to this next one. Suppose that there had been 200 head circumferences measured. Here I only had here I only had 40. What if I had 200? Explain why you might prefer to summarize this data using a histogram instead of a dot plot. So if I have a larger data set, I have 200 instead of 40, why would a histogram be better? Well, it's actually pretty simple. If I tried to create a dot plot, there would be too many dots. It would take a long time to create. All right. So now let's go back up to looking at a histogram before we continue with our next one. Here's my histogram diagram again, and there's some things that I want you to notice. The first one is this little doohickey, or this little guy right here. That is called a scissors cut. Normally when we're making our graphs, we want our data to be spaced out evenly. What I mean by that is you'll see all these intervals down here, They're all by 20. 20, 20, 20. If we're skipping some data values, 0 all the way to 510, I'm skipping all those numbers since they don't have any data points. I just use this scissors cut. That lets me know that I'm skipping. I'm not going in equal intervals for that portion. What I also want you to notice is this histogram, all of its lines are touching. All of the boxes are touching each other. Why do you think that is? Well, they're touching because it's a range of value. I'm not skipping numbers, so this goes all the way to 550 and stops. And then this box starts at 550. So all of my values should be touching because they're all being represented. All right, let's go to our next example. A histogram is useful to describe the shapes of data distributions. It is important to think about the shape of a data distribution because, depending on the shape, there are different ways to describe important features of the distribution, such as, look at that word again, center and variability. Those are the two words that we use most often when describing a distribution. A group of students want to find out how long a certain brand of AA batteries lasted. The histogram below shows the data distribution for how long that some AA batteries lasted. Looking at the shape of the histogram, notice how the data mounds up around a center of 150. What does this word sound like? Mounds is related to what? Mountain. So it mounds up around that 105 right here. We would describe the shape as mounded or symmetric. So if it's a mountain that's kind of even on both sides, we say it is a symmetric mound. If we were to draw a line down the center, notice how each of the histogram is approximately the same or mirror image of each other. This means the data is symmetric. So notice I draw this line right down the middle, and I have tall ones on left and right, medium ones on left and right, and then these super tiny ones. So that means our data is symmetric. Okay, another group of students wanted to investigate the maximum drop length for roller coasters. The histogram below shows the maximum drop in feet of a selected group of roller coasters. This histogram has what's called a skewed shape. So we have symmetric and skewed. Most of the data intervals are from 150 to 170. But there are two values that are usual. Hey look, there's that word again, typical, or not regular when compared to the rest of the data. These values are much higher than the others. Notice how when it's saying higher, it's referring to the feet, not the frequency. It's referring to the feet. So what do we notice about this? Well, what I should notice is that if I draw that line down the middle of where the center is, my left side is not the same as that right side. So they're not the same. So this is going to be what's called skewed. This is when my data does not have that same representation. If I draw kind of an outline on it, I see that there's a large hump, but there's nothing on the other side that's that same interval, that same amount. So this is what's called a left skewed. This is called a right skewed. And the reasons why it's called a right skewed is because it has a tail on the right. So a right skewed has a right tail. If the tail was on the left side, this small piece was over here, then it would be called a left skewed. All right, here we go. Here's another histogram to look at. The histogram below shows the highway miles per gallon of different compact cars. Compact meaning tiny. Describe the shape of the histogram as approximately symmetric, skewed left, or skewed right. Well, let's look first. If it's symmetric, that means if I draw a line right down the middle of the data, my left side should be about the same as the right. It's not the same as the right and left, so I know it's going to be skewed left or right. So let's think. if I draw my outline, where is that tail? Well, that tail is on the right, so it is a skewed right. All right, my next question is this. Draw a vertical line on the histogram to show where the typical numbers for miles per gallon is. Well, here's an acceptable one, but what's even more precise is if I draw it in the middle of that range. If I draw it right here in the middle. So what would my typical miles per gallon be? Well, it's going to be somewhere right in here, right in that middle. So maybe 35 I can put, or I can be even more precise and say 35.5. All right, let's go to our next one. This next one's going to ask us to describe our data. What does the shape of it tell you? Well, the shape tells me a few things. It tells me that most cars get around 31 to 40 miles per gallon, that MPG. However, there was one car that got between, and look at that misspelling, so I'm going to go back and correct it, 49 and 52 miles per gallon. So that's what that shape is telling me. It's telling me most of my data was in this area, but there's one car who is way out here. All right, we're going to skip number 11, and let's keep on going down to number 12. Okay, so we're back to that head circumference idea. Another student decided to organize the head circumference data by changing the width of each interval to be 10 instead of 20. So when we first created it, this was from 5 to 5:30. Now they've made into intervals of 10. Below is the histogram that resulted. How does this histogram compare with the histogram of the head circumference that you complete in exercise 5? Well, there's several things, but this is one thing we should notice. They both have the same general shape and size. How do we know they have the same general size? Well, my values are all the same. And also, based on that piece of information, I also know what? They have the same center. So I can add that as well. If I'm using the exact same data, then my center should be the same as well. Which means that the center is the same as well. Okay, there's one more thing though that I do need to add to it. This one is not what? However, this histogram is not symmetric. Let's look at that. If I draw the outline, this one is what's called slightly skewed left because there's a tiny tail on the end, so it's slightly skewed left. However, what we can notice is what? It's pretty much close to the same. So we can, if we want, say that it is symmetric because it's pretty much the same, but it's not as symmetric as my other one. So what I can do is I can just put this little qualifier in. However, this histogram is not as symmetric because it's still pretty much the same. We can have slightly skewed or we can say it's still symmetric, just not as symmetric. All right, here's my next question on here. How many head circumferences are in the interval? In this part, we need to be careful. 570 to 590. So I need to look up here, and where is that 570 to 590? Well, it's all these values. So it's not just this, but it's this part and this. So that is 4 and 5, which is 9. So how many head circumferences are in there? There are 9. Here's my next one. In what interval would a head circumference of 571 be included? What about 610? Well, let's look up here. I'm looking for 571 and 610. Well, the 571 is pretty easy. I look, 571 is in between 570 and 580, so it's going to go in here. So my interval would be 570 to 580. This 610 one, it's right on the line. So which one does it go into? Well, remember, it's less than this. This is 600 to less than 610. This is 610 to less than 620. So it's going to go in this interval right here. It's going to go in the 610 to 620. All right, we're almost done with our lesson for today. We just have our summary left. All right, a histogram is a graph that represents the number of data values falling in an interval with the bar. So this is our most important idea to take away. It's data values falling in an interval. The horizontal axis shows the intervals and the vertical axis shows the frequency. Each interval should be the same length or width and the bars should touch each other. All right, what you're going to do is this. You're going to complete your exit ticket. And turn that into the turn box. Okay, your exit ticket is going to be with Ian, so collect it from Ian. After you have turned your exit ticket in, then you can go to Dreambox until the end of the day. If you need your password for Dreambox, it is on the small whiteboard. And good job today.